One of the special cases with index laws is that anything to the power of 0 is equal to 1. So if I had 523 million to the power of 0, that would also be equal to 1. Anything to the power of 0 is equal to 1. So why? There's a couple of ways we can work this out. So let's go and have a see what we can do to prove. Probably one of the easiest ways to prove this would be if I was to have, let's say, 4 to the power of 4 divided by 4 to the power of 4. So 4 to the power of 4 divided by 4 to the power of 4. Well, 4 to the power of 4, okay, so we have to think about what that is. So that would be the same as 2 to the power of 8. Oh, 4 to the power of 4, 4 times 4 is 16, 16 times 4 is 64, 64 times 4 would be equal to 256 divided by 256. 256 divided by 256 would be equal to 1. And if I use my index laws, 4 to the power of 4, take away 4, because that's what this would be, which is 4 to the power of 0. So therefore, 4 to the power of 0 must be equal to 1. So, another means to prove it. And another way to prove it is to have a look at the pattern. So if I had, let's say, 3 to the power of 1, 3 to the power of 2, 3 to the power of 3, 3 to the power of 4, 3 to the power of negative 1, 3 to the power of negative 2, 3 to the power of negative 3, 3 to the power of negative 4. What is 3 to the power of 1? Hopefully you might remember that 3 to the power of 1 is just the number itself. So that is 3. So 3 to the power of 1 is 3. So if you see a number without any power whatsoever, that's just the number itself. So 2 to the power of 1 is 2, 10 to the power of 1 is 10. That kind of thing. 3 squared, 3 times 3 is 9, 3 times 3 is 27, 3 times 3 times 3 times 3 times 3 is 81. So the negative power, remember, is the fraction. So this will be 1/3, this will be 1 over 3 squared, which is 9, this will be 1 over 3 to the power of 3, which is 127. And this is also 1 over 3 to the power of 4, which would be 81. So we need to figure out what's the missing link. What's the missing link that will continue this pattern? What's happened? How is this a pattern increasing? Well, from here to here, timesing by 3. From here to here, times by 3. Because 1 over 81 times 3 would be 1 over 27. Times that by 3. Times that by 3. From 3 to 9 is times by 3. Times by 3. Times by 3. So definitely we know that the pattern is increasing. We have to multiply by 3. So therefore, what's 1/3 times 3? Well, that has to be 1. And what's the next one in the pattern? Negative 4, negative 3, negative 2, negative 1, something. 1, 2, 3, 4, well, have to be 3 to the power of 0. So you can see there from an index law point of view why this is the case, and also from a pattern point of view why this is the case.